Hello friends, welcome to my channel SB Engineering Education, which is for GATE and PSUs. Today I am going to discuss another two very important standard signals. One is you can say Gaussian signal, other signal you can say two-sided exponential signal. That means one signal you can say Gaussian, other you can say two-sided exponential. Two-sided exponential signal. So these two signals having the application in our signal system topics, and also you will find the application in your communication subject. Anyway, so first let me cover what is basically a Gaussian signal. Try to understand how to plot this Gaussian signal. This is very important. Try to remember the equation of Gaussian signal and also try to plot the Gaussian signal. How I will plot, what concept I will use for the plot of Gaussian signal, try to mark. See, e to the power minus pi t square. This is the equation for Gaussian signal. That means suppose you just consider xt is equal to e to the power minus pi t square. This is a signal equation you can say, because any signal you just consider with respect to time. X is a function of time. You have to plot with respect to time. That means you will always take this abscissa as a time axis. So accordingly you just plot x is a function of time, that is equal to e to the power minus pi t square. This is a signal plot because this is a function of time. Anything which is a function of time, that is basically signal plot. Anything means here any physical quantity which is a function of time, that is basically signal, I have told. Anyway, x is a function of time, that is e to the power minus pi t square. This equation is nothing but known as Gaussian equation, and what are the plot you will find for this equation, that is known as Gaussian plot. See here how to plot it, very important, how to plot it. So for the plot, let us consider first t is equal to minus infinite. If you take t is equal to minus infinite, that means x of minus infinite, in place of t you just use minus infinite. X of minus infinite e to the minus pi, in place of t you just take minus infinite. This is minus infinite square, which you will find e to the minus pi minus infinite square, again plus infinite square, again you will find infinite. You can say infinite square, you just take infinite in general, but actually infinite square is different from infinite. Actually this is different from infinite, but let me consider infinite square again infinite. That means e to the minus pi into infinite, you will find e to the minus infinite, it is equal to 1 by e to the power infinite, it is equal to 1 by infinite, it is equal to 0. That means at t is equal to minus infinite, this signal having value 0. Now, suppose you just take t is equal to 0. If you take t is equal to 0, then here you just put t is equal to 0. X of 0 is equal to e to the power minus pi 0 square. E to the minus pi 0 square is 0. That means e to the minus 0. That is 1 by e to the power 0. This is your 1 by 1. This is your 1. That means at t is equal to 0, you are getting value is 1. Very important. T is equal to minus infinite, value 0. T is equal to 0, value 1. Now let us see what happens at t is equal to plus infinite time. At t is equal to plus infinite, what you will find? X of infinite. X of infinite. That is equal to e to the minus pi t square. T square means infinite square. In place of t you are using infinite. That is equal to e to the minus pi into infinite. That is equal to e to the minus infinite. That is 1 by e to the power infinite. That is 1 by infinite. Again you are getting 0. See here. At minus infinite, value 0. At 0, value 1. At infinite, value 0. Knowing these informations, let us try to plot for this e to the power minus pi t square, which we are saying Gaussian equation. So how to plot this signal? These are the informations what I have find out. So now knowing these informations, let us try to plot this Gaussian signal. See here, what values I have got at t is equal to minus infinite. This is your time axis. T at t is equal to minus infinite, I have got the value 0. T is equal to plus infinite, I have got the value 0. And t is equal to 0, I have got the value 1. So therefore, you can guess two types of plots. One plot is this. One guess you can make this. Other case, you can make this. See here. Here t is equal to infinite value 0. Here t is equal to minus infinite value 0. Here t is equal to 0 value 1. Similarly, same things you can get for this. T is equal to infinite value 0. T is equal to minus infinite value 0. T is equal to 0 value 1. Then which plot is the actual plot for this Gaussian signal? Actual plot is this. Why the actual plot for Gaussian signal is this? For this, there is a concept. What is the concept? Whenever there is a derivative for a signal, suppose you want to find out the derivative of a signal. What is the physical meaning of derivative? Derivative means slope of the tangent. Suppose there is a function which is a function of time, that means what you are saying signal. Suppose there is a signal. If you differentiate this signal with respect to time, then you will find another signal. Derivative of one signal is another signal. Simple concept. Suppose you are having xt. Now if you differentiate this xt with respect to time, that means you will find another signal. Suppose it is yt. Anyway, if this is a signal, after derivative of this signal, you will find yt. What yt represents? Yt represents slope of the tangent of xt for every time t. Again I am repeating. This represents slope of the tangent of xt drawn at any time t, because that is also a function of time. Now here what you will do? So your Gaussian equation for xt, Gaussian equation is e to the power minus pi t square. If you differentiate it, dxt by dt, what you find? Minus pi, again to t square derivative to t, again e to the minus pi t square. So this equation represents the slope of the tangent of this xt, slope of the tangent of e to the minus pi t square at any time t. Again I am repeating, this equation represents slope of the tangent of this curve at any time t. Now suppose t is equal to 0, then what is the slope of the tangent at t is equal to 0? Now find out the value here. T is equal to 0, put here dxt by dt. This is the slope of the tangent at any time t. Now for any time t, you just put t is equal to 0, you will find minus pi 2 into 0, that means you will find 0. The curve whose slope of the tangent at 0 at t is equal to 0, that must be for the Gaussian signal. Now there are two plots you have guessed. Now at t is equal to 0, if you draw the tangent here, you will find the tangent is this. But if you draw the tangent here, you may get this is the tangent or you may get this is the tangent. But these two tangents having slope not 0. This tangent definitely having a slope 0. You know, any line parallel to horizontal line, the slope is 0. So therefore, this will be the plot for Gaussian signal. This will not the plot for Gaussian signal. So Gaussian signal is drawn in this manner. This is very, very important. So that means you just mark, whenever you are considering the Gaussian signal, you may draw the plot for Gaussian signal in this manner. This is your Gaussian signal at 0 value 1. So e to the power minus pi t square. But if you mention a e to the minus pi t square, then r 0 value is not 1, r 0 value is 8. That is very simple. Because if you put t is equal to 0, e to the 0 is 1. Here e to the 0 into 8, that means you will find 1 into 8, that means 8. So anyway, this signal is Gaussian signal, and this signal is even signal, because if you put a mirror here, this side reflection will over here, over this plot, and this side reflection over this plot. So therefore, this is basically an even signal. So this is the discussion about Gaussian signal. In future, I will say, if you find the Fourier transform of this Gaussian signal, you will find the shape is again Gaussian. There is only one signal whose Fourier transform is also having the same shape as in time domain. So that things I will cover in the discussion of Fourier transform topic. So anyway, here this particular signal is known as Gaussian signal. Now let me discuss another standard signal. Actually this is not a standard signal, I am considering it as a standard signal because it having the application many times you will find in this signal system topic. So this is e to the minus a mod t. This particular signal, how to sketch this signal and what is the idea about this signal, let me cover here. Let it be xt. Any signal I may consider that is a function of time, let it be xt. Now how to plot this? Now you know the definition of a mod t. Mod t is equal to plus t when t greater than 0 is equal to minus t when t less than 0. Now use the definition of a mod t here. Now if you use the definition here, what you find? X of t is equal to e to the minus a mod t is equal to t, put here t. When t greater than 0, write t greater than 0. Again is equal to e to the power minus a mod t is equal to minus t, write here minus t. When t less than 0, write here t less than 0. That means this will be the equation if you use the definition for mod t. Then see here xt is equal to e to the power minus 80 for t greater than 0. Again minus minus plus, you may write e to the power plus 80 for t less than 0. Now see, in both cases you may use equal sign. Here equal. Why? Because if you put equal 0, e to the power 0, 1, e to the 0, 1, both cases you are getting same value. So no problem. In both you can put equal to. It is t greater than equal to, it is t less than equal to. There is no problem, there is no harm. So here xt is equal to this much. Now see, you know the plot for e to the minus 80. It is basically exponentially decay function. Yes, I have covered already. This is exponentially decay function. At 0 value is 1. Now you know this plot. This is exponentially rising function. This function r 0 value is 1. But this function you have to plot for t greater than 0. That means only this side. This function you have to plot for t less than 0. That means you have to plot this side. So that means you will find the plot of this e to the minus 80 for t greater than equal to 0 as this. Only this side. T greater than equal to 0 you have to plot value 1. Again you will find the plot of e to the 80 for t less than equal to 0. You will find this. You will find this. Now combining these two, because these two is nothing but e to the minus a mod t. So what you will find? This is the plot. This is known as both-sided exponential signal. This is both-sided exponential signal. And what is the equation? E to the minus a mod t. So this is another important signal. So now I think I have covered about the standard signals. In my next video, I will summarize all these standard signals. Then I will switch over to other discussions. Anyway, thank you very much. Please subscribe my channel. Please like my videos so that I will be motivated more to make more and more videos. Again, please share my videos so that it will reach to more number of students. Please press on the bell icon so that whatever the notification I have, that will reach to you first. Thank you very much.